Okay, this video is going to take the condensed structures that we figured out in the last video and make them even simpler. And so what we're going to talk about today is what we call skeletal structures, which make a lot of assumptions that you know what you're talking about with organic chemistry. With skeletal structures, we're going to assume that every atom that we have in a molecule is carbon unless we tell you otherwise. And not only that, we're going to assume that every carbon in the molecule is saturated with hydrogens unless we tell you it's not. So let me give you an example to help explain this. Here we have a 2-carbon molecule, ethane, and it is totally saturated with hydrogens, right? If each carbon has to have 4 bonds, we know that this carbon is bound to that carbon and that the other 3 bonds are from hydrogens. So the way to draw this in a skeletal structure is just to say with your pen, here's one carbon, it's attached to another carbon. That is the skeletal structure for CH3. I have 2 points on my line. These are terminal points, the start of the line and the end of the line. I don't have to have points there. Just this is just a line. And I know that that has to be a carbon. That has to be a carbon because I didn't tell you they weren't. And that each carbon, if I don't tell you what else it's bound to, has to be saturated with hydrogens. This is one carbon bound to another carbon. Its other 3 bonds have to be hydrogens. The same here. I don't have to tell you that though. Okay. Now for simple molecules like ethane, this looks boring, but it makes things so much easier as we get to more complicated molecules, especially with branching. Okay, here's a branched alkane. It's got 4 carbons with it. These 3 carbons are bound directly together, and then there's a branch, at least the way I've got it drawn here. So here's 1 carbon, 2 carbon, 3 carbon. Okay. Each terminus indicates a carbon, and any joint in the middle, any bend or angle in the middle indicates another carbon. So here's a carbon, here's a carbon, here's a carbon. These are these 3 carbons here. This central carbon has another carbon off of it, so I can draw that like that. I have 1, 2, 3, 4 carbons in the molecule. All the other bonds are bound up with hydrogens. Okay. Here, let's do this molecule really easily. One thing that's helpful to start thinking about, especially as we get into nomenclature, is how many carbons are in a continuous series here. So I can go 1, 2, 3, 4 carbons without backtracking. So I'll just say 1, 2, 3, 4. There's my 4 carbons that are the parent chain of this molecule. And then on this carbon, right, the 3rd carbon, I have 1 CH3, which I've already indicated as part of my parent chain, and I have 2 more. Boing, boing. That's this molecule. There's no other atoms in there. Each of these carbons have all their other bonds taken up by hydrogens, so I don't have to do anything else. Here with this alkene, 1, 2, 3, 4, has 4 carbons. I can indicate the double bond by showing a double bond. This one, okay, has some non-carbon atoms in it. So first I'm going to indicate how many carbons are in there. There's only 2 carbons in this molecule, CH3, and then this interesting carbon here. When you don't have carbons, you have to tell me, right, in these skeletal structures. And so for this carbon at the end, I just have to pretty much write it out to say that carbon, this carbon here, has a double bond to an oxygen. It also has a single bond to an oxygen. And when you have hydrogens that are not bound to carbons, you have to tell me that. You have to show me. And so I can just indicate that this oxygen has 1 hydrogen associated with it. This will be the skeletal structure for this molecule here. If things aren't carbon, or if you have hydrogens that aren't bound to carbon, you have to indicate that. Okay, here's another molecule, pretty easy. Really, one way to think about it is what's your longest carbon chain, continuous carbon chain, 1, 2, 3. So just start with that, 1, 2, 3. Now this first carbon has a chlorine associated with it, so I'll draw a bond and I will end it with a chlorine. Okay? If your line ends with another atom, you don't say that's a carbon and I have a chlorine. You just say that this carbon is bound to a chlorine. I still only have 3 carbons here. The second carbon is bound to a methyl group, CH3, which I've indicated here, but it's also bound to an OCH3. I can write it up or down, it doesn't matter, but I have to tell you that that's an oxygen. It's not a carbon. And then this oxygen's bound to a CH3. I can just draw another line. Here's my CH3. That carbon's directly bound to the oxygen. This oxygen is directly bound to my parent carbon in the middle. Cyclic molecules are a piece of cake. There you go. Each of the joints in my pentagon is a carbon, and they are saturated with hydrogens. For example, I know this is a carbon. I know it is bound to this carbon and to that carbon. It needs 2 more bonds to have 4 bonds, so they must be hydrogens, CH2. I don't have to tell you I don't have to write out those carbon-hydrogen bonds. They're just understood.